We're going to talk tonight about division properties of exponents. We've done zero exponents. We've done negative exponents. We've multiplied with exponents, so now we're going to work on the division portion of them. So the first thing we have is what's called the quotient of powers. And it says to divide, what we have to do is we again have to have the same base, but what we'll do is we'll subtract the exponents. So what that means is I have something like a to the m divided by a to the n power. And like before when we added the exponents m and n, here we subtract them. A to the m minus n power. So that's the basic form of it. We'll also use this formula in a different format, and we'll refer to it as canceling. It is easier to show with a couple of our examples that we'll see here shortly. So I'll show that to you here in a little bit and refer to it as canceling. Our other property here is the power of a quotient. Okay, the power of a quotient. So let's say what that is referring to here is we have something like a over b all raised to the m power. What this is saying is that everything inside that set of parentheses has to be raised to the m power. So this would be equal to a to the m over b to the m power. That's how those work. Just like before when we had the power of a product, everything on the inside got raised to that particular power. So that's what we have here. Those are the formulas. Make sure we have the notes written down with them and the formulas. I'm going to show you a few examples of each here. So as we look at this first one on the left, I'm going to do it in two ways. Okay, the first, I'll do the subtraction. I will do the subtraction. So we would have x to the 3 minus 5 with the same base. We have a quotient. We subtract the exponents. This would be equal to x to the negative 2. Remember, back to the negative exponents, nothing is ever simplified with negative exponents. So we have to take this from the numerator, because it's over 1, take its reciprocal, make it 1 over x to the second power. That's one way to do that. Now that canceling way that I referred back to is, this is going to be a lot longer than you normally have to do it, but this is just where it all comes from. If we remember that x cubed is x times x times x, and that x to the fifth is x times x times x times x times x. Okay? And what we're allowed to do is we're allowed to cancel. X divided by x cancels out. X divided by x cancels out. X divided by x cancels out. So what we're ultimately left with is x times x in the denominator and 1 in the numerator. So we get to the same answer by canceling out. What I'll refer to here is all three of these will cancel out, and we'll be left with 2 down here. So our variable will end up in the numerator or denominator depending on which of those had the greatest exponent. Here, x to the fifth has a greater exponent than x to the third. That's why the x squared remains in the denominator. So if we look at the next example here, x to the 11th over x to the 5th. Again, the subtraction would work here, but let's talk about the canceling, because it's going to be more useful for us down the road. I have x to the 11th and x to the 5th. So that tells me that my x's are going to remain in the numerator when I'm done, because 11 is greater than 5. So what will happen is all 5 of these will cancel and give me 1. The 11, I have to take 5 of those away. 11 minus 5 is 6. We end up with x to the 6th in that particular problem. So again, canceling out is going to be very useful for us. And this last example, I'll come back to the subtraction. This is x to the 9 minus 8, which is just x. So that's the subtraction or the canceling method there, some basic examples What's going to happen as these get more challenging, all of these properties will be tossed in together. We'll ultimately see that during class here over the next few days. But let's take a look at a couple of the power of a quotient properties here in examples. And that'll be it for tonight. So let's take a look at this first one. The quantity 3 over x all cubed. So everything inside there gets raised to the third power. So this would be equal to 3 to the third over x to the third. Again, everything inside gets raised to that power 3. 3 to the third is 27. We end up with 27 over x cubed as our final answer there. Moving on to the next one, actually the next two, we have to make sure we're very careful. Especially like in ones like this, where we have the quantity 2x over y squared all cubed. This 2 has to be cubed in addition to the x being cubed. Every single term, and the constants are part of those, have to be raised to the third power. So this would be equal to 2 to the third times x to the third, all raised to, or divided by y to the 2 times 3, because that's a power to a power there. Well, 2 cubed is 8 times x cubed, and then 2 times 3 would give us y to the 6th power. That's the final answer there. So the power to a power property from a couple days ago still applies, and we have to make sure everything inside gets raised to that third power. So as we look at our last example for the night, I have the quantity 3y cubed divided by 2x squared y all cubed. So if we take a look, everything in here has to be raised to the third power. So this is 3 to the third times y to the 3 times 3 power. Power to power we multiply. All over 2 cubed times x to the 2 times 3 power times y. So finally we simplify this. 3 cubed is 27. 3 times 3 is 9, so we have y to the 9th. All over 8 x to the 6th y. And we would need to do one more simplification here, because I have y to the 9th over y to the 1st. So this y would cancel. This would become y to the 8th power. So my final answer for this one is 27 y to the 8th all over 8x to the 6th. That's our final answer. That's your final example for the night. I hope you have a great evening, and we'll see you tomorrow.